Number 1. Shown below is a velocity versus time graph for an object. Describe the motion of the object. So we know that the velocity equals the slope. So up here it has a slope of 4 and it's in the positive direction because it's on this side and it's going for 2 seconds. And then it changes directions and goes into the negative as it travels at a slope of -3, and this travels for 1 second. And it's negative because it's on this side of the axis. And then for 2 seconds, the object remains at rest because the line is at 0, so therefore the velocity is at 0. B. Draw the corresponding position versus time graph. Number the x-axis. So here's the position versus time graph that I drew. And I drew this because from the velocity versus time graph, you can see that it has a slope of 4. So you add 4 each time, so it goes all the way up to 8. And then it subtracts 3 as it goes down and switches directions. And that's for 1 second, so that's 3. And then remains still. Number 2. A race car travels at a constant speed of 95 miles per second. How far does it travel in 12.5 seconds? Use the appropriate mathematical expression and show how units cancel. So for this, I use the equation of displacement because it is asking how far the object traveled. And the equation for displacement is the velocity times the time, and the velocity also equals the speed. So therefore you would plug in 95 miles per second for the velocity, and then plug in the time, which is 12.5 seconds, and that equals 11875.5 meters. And through this, the seconds cancel as you multiply them. Number 3 says, using the position versus time graph below to answer the following questions. So this is a position versus time graph, and A says, determine the object's displacement between t equals 0 and t equals 10. So displacement is from where you start to where you end up. So it started here at 0, then it went up to 10, which would be 60. And the equation for displacement is the velocity times the time. And the velocity of this is 6 because it is a change over the x and y. So 60 divided by 10 equals 6. So you do 6 times 10 equals 60, and that's the displacement. B. Determine the object's displacement between t equals 0 and t equals 30. So from here at 0 to 30. So again, V times t equals displacement. So 0 times 30 equals 0. So the overall displacement is 0 because it ends up at the same place. C. Determine the object's distance traveled between t equals 0 and t equals 30. Distance is different than displacement. Distance is how far the object traveled, not like from where it started and where it ended, like, the positions. So it's asking from t equals 0 and t equals 30. And in 10 seconds, it goes up to all the way to 60, so that's a distance of 60. And then by 30 seconds, see, it doesn't move right here, but then it goes another 60. So you just add the 60 and 60 together to equal 120, so that's the distance. D. Determine the object's average velocity between t equals 30 and t equals 40. So here's t equals 30 and t equals 40. And the velocity is the displacement divided by the times. And the displacement of this equation of this problem is -4 because it's traveling -40 in only 10 seconds. So that's how I got -4. So then you just divide, you multiply it by 10 because that's the time. V times t is the displacement, and then you divide by 10, which equals -4. And then E, determine the object's average velocity between t equals 0 and t equals 55. So here's t equals 0, here's t equals 55. And again, you would take the change over x, which is 0, because it's on the same line. and then divided by 55, which is the time. So the overall average is 0.